So the tangent function is a combination really of the sine and cosine, which I'm going to explain in a moment. You should have seen the tangent before in geometry. In SOHCAHTOA, it is the TOA part, which is the opposite over the adjacent, which is really how I like to write it, all right? Now, what they want us to do for the next part, I'm only going to do part A. They want us to find the sine, the cosine, and the tangent of theta, which has been cut off. It's right here. So they want us to find all three trig functions. We need all three sides, though, in order to do that, and we are missing a side. Now, if you want to, you can use the Pythagorean theorem to find that last side. I'm not going to because I do recognize that this is a special right triangle. It's a 3, 4, 5 triangle, okay? So let's find the trig functions. So sine of theta is opposite over hypotenuse, which is, so here's my right angle, and across from that is the hypotenuse. That's the easy part, in my opinion. So the hypotenuse is 5. Now, if this is the angle that we're talking about, theta, which one is opposite? It's the one that isn't touching it. It's across from it, so it's 3/5. Now, if I want to do the cosine of theta, it's adjacent over hypotenuse. I'm still talking about the same angle, so my hypotenuse doesn't change, and adjacent means next to, and that's the 4. So it is 4/5. So this is my sine, this is my cosine, and now I'm going to do the tangent, which is the opposite over the adjacent, and I'm using the same angle. So the opposite is 3, the adjacent is 4, so the tangent is 3/4. Notice how the sine and the cosine both have the hypotenuse in their denominator. And if they were to disappear, or if I were to divide one by the other, that would give me 3/4. And that is really where the tangent function comes from. It's as if I were to divide the sine by the cosine. So this little definition down here, the definition of the tangent function in terms of sine and cosine, the sine divided by the cosine, this is very important. This comes into play with everything that we've been doing with the unit circle. Now, lucky for you, we will not be graphing the tangent function. Let me just show you real quickly what the tangent of x looks like. So this is the tangent of x. It looks pretty crazy. The reason why it looks like that is because it's actually division, right? It's sine over cosine, which means that there's a lot of things that are going to make it undefined. So there's all these asymptotes. So lucky for you, you are not going to have to graph it. But it is at least good to know what it looks like if you ever see it anywhere, or you will see it next year in pre-calc. So when we first started talking about sine and cosine on the unit circle, we talked about what the x and the y stood for, and basically we just determined that the coordinates are cosine and sine. Okay. I am not going to do this example for the sake of confusion, and really if you do have an understanding that the tangent is the sine over the cosine, that's kind of explaining where this came from. But if you can remember that, you're in good shape. So we had this unit circle, right? And we had angles that were drawn. So for example, this was 30 degrees, right? And there was a coordinate right here. And we did 45 degrees and 60 degrees, and you had to memorize the coordinates. And the coordinates for 30 degrees were the square root of 3 over 2 and 1/2. So if you were asked for the cosine of 30 degrees, you would give the x value. It was a square root of 3 over 2. And if you were asked for the sine of 30 degrees, you would say 1/2, right? And then there were other angles that had the same exact coordinates. There was this one here, that was 150. There's this one here, that was 210. And this one here, that was 330. Those are all the 30-degree angles because they are all 30 degrees away from the x-axis, or away from the 180 and the 360, okay? Now, the only thing that changes in the coordinates are the sign. So for example, my x value here is negative, so it's negative the square root of 3 over 2, 1/2. In the third quadrant, everything is negative, right? And then in the fourth quadrant, only the y value is negative, right? And then you had to memorize these. And then there were 60-degree angles that you had to memorize and 45-degree angles that you had to memorize. So I'm going to write a summary here. If this is not the first, if you're feeling confused by this, you definitely need to go back to lesson 2, which is still on the YouTube. You should still have your notes on it. But I am going to give you a summary, but if it's confusing you, you definitely need to go back or you need to speak with me. So your first set of coordinates that you had to memorize was the square root of 3 over 2, 1/2. So remember, this is the cosine, that's the sine, right? So these are your 30-degree angles. So it's 30 degrees, 150 degrees, 210 degrees, and 330 degrees. Then you had to memorize your 60s. And the nice thing was that the coordinates were almost exactly the same, but they were flip-flopped, right? So now your cosine is 1/2 and your sine is the square root of 3 over 2. And now your 60s were the 60-degree, 120, 240, and 300. Now these are all 60 degrees away from the x-axis. And then the last one that you had to memorize was your 45s. And those were the square root of 2 over 2, the square root of 2 over 2. And your 45s were 45, 135, 225, and 315. And the only thing that's going to change is the sign depending on which quadrant you're in. This is just a little cheat sheet here, but here you're positive, positive. That's easy to remember. Third quadrant, you're negative, negative. That's easy to remember. Here, your cosine or your x is negative, but your y is positive, and you're exactly the opposite in quadrant 4. Some teachers make you memorize that. I don't. I feel like it's just logic. It's one less thing you have to memorize. Just think about what quadrant you're in and what your sign would be if you had to plot a point there. All right, now the next page of the notes. Now, given the definition that we just talked about, sine divided by cosine, if we're going to find the tangent. So you do need to know those angles that we just reviewed, all right? So if I want to find the tangent, so each one we have to find the following value. If I want to find the tangent of 60 degrees, it is the sine of 60 degrees over the cosine of 60 degrees. I'm just going by this definition. So what is the sine of 60 degrees? So sine is the y value, and we're in quadrant 1. So it's the square root of 3 over 2 that I'm getting from the angles that I've memorized. And the cosine of 60 degrees is 1/2. Now, you can, in your calculator, do the square root of 3/2 divided by 1/2. I'm just gonna hope that you trust me that, if you were to actually show the work and divide this out, the two denominators cancel. Just like it's like the hypotenuse in the example in the first page that I gave you. So you really just end up with the square root of 3/1, which is the square root of 3. And that's all you have to do, really. So let's move on to the tangent of 45. So it is the sine of 45 degrees over the cosine of 45 degrees. Well, I need to refer to the angles that I need to have memorized. 45 degrees is in the first quadrant, so everything's positive, so we don't have to worry about that just yet. So the sine of 45 is my y value, which is the square root of 2/2. And my x value of 45 is the same. It's the square root of 2/2. Well, what is anything divided by itself? 1. Okay, so on C, it's the tangent of 150. So I'm going to do the sine of 150 over the cosine of 150. So 150 is now in the third quadrant, so we need to think about our signs, okay? So 150 is a 30 degree, it's one of the 30-degree angles. So if I'm in quadrant 2, I need the sine or the y value, and that is 1/2, and that is positive. But my cosine or my x value is negative, and the cosine is the square root of 3/2. And just like I mentioned in example A, your denominators cancel, so you're really ending up with 1 over the square root of 3, and it's negative because you have a positive divided by a negative. Part D is the tangent of 180 degrees. So I'm going to write this as the sine of 180 over the cosine of 180. Now, 180 is not on those three lists that you had to memorize. 180 degrees is right here, correct? Well, what are the coordinates there? If it's a unit circle, it's -1, 0. So what is the sine of 180, or what's the y value? It's 0. What's the cosine of 180? It's -1. What is 0 divided by -1? 0. So that is the answer there. Little reminder that you can divide into 0, but you cannot divide by 0. So you can have 0 on the top, not on the bottom. Exercise 2 says, consider the angle theta equals 90 degrees or pi over 2 radians. State the values of the sine and the cosine at this angle. Why would the value of the tangent of 90 degrees be undefined? So this is what I was just talking about. So very quickly, I'm just going to show you on the graph that 90 degrees is right here, correct? Right, that's 90 degrees. What are the coordinates there? Be very careful with your zeros. It's 0, 1. So what's the sine of 90 degrees? It is 1. What is the cosine of 90 degrees? 0. So if the tangent of 90 degrees is the sine divided by the cosine, I have 1 divided by 0. So as I just mentioned, you cannot divide by 0, so you say it's undefined. And also, isn't this a straight line, right? So it's undefined. Okay. Because the tangent function involves division, there is a chance it could be undefined when the cosine equals 0, right? Where's the other place where the cosine is going to equal 0? Right here at 270 degrees, right? That's 0, -1, which I just gave the answer away. But at which of the following angles is the tangent undefined? So you can do the tangent of the whole thing, but they don't really want the tangent only. They want to know it's undefined. So we really just need to look for when the cosine is 0. So at 0 degrees, well, the coordinates there are 1, 0. So that's my cosine. At 270, there's 0, -1. So right there, the answer is 2 because my cosine is 0. So I would do -1 divided by 0, undefined. However, the cosine of 120 degrees is 1/2. And the cosine of -180, well, -180 is the same as +180. You just go backwards, but it stops at the same spot. So it's -1, 0. Well, the cosine there is -1. So that's more reason why it's choice number 2. Next page, they want us to find all 3 trig functions. This is a very common question. Eventually, you're going to be finding 6 trig functions, but for now, it's 3. Actually 2 because they're giving you 1, but it says determine the value of the cosine of theta and the tangent of theta if the sine of theta equals 5/13 and the terminal ray of theta lies in quadrant 2. We've done these before. We just are now finding the tangent as well as the sine or the cosine. So something that's important is they're telling me it lies in quadrant 2. So I'm going to draw this. I'm just going to sketch it. So I'm in quadrant 2. The quadrant does matter because it affects your sines. So theta is always going to be the angle closest to the origin, and I'm always going to draw a line straight down to 180, or the x-axis, not the y-axis, okay? So I'm going to have to use SOHCAHTOA to help me here. I know that my sine of theta equals 5/13, which is opposite over hypotenuse. So if I go back here, this is my right angle, which makes that my hypotenuse, which is 13. Now, theta is here, so which side is going to be the opposite? It's the one that's not touching it. So it's that. I do need this side here if I want to find the cosine and the tangent. You can use the Pythagorean theorem if you need to. I am recognizing, though, that this is a special right triangle. It's a 5, 12, 13 triangle. If you didn't recognize that, that's fine. Use the Pythagorean theorem. All right, so now that I have all 3 sides, I can do all my trig functions. So the cosine of theta is the adjacent over the hypotenuse. The adjacent is 12. The hypotenuse is 13. Now, distance is always positive. However, we need to keep in mind that if we're in quadrant 2, if technically that's a -12, right? My x value is going to be negative, right? This is my x value, so it's going to be negative. Now, the tangent you can do 2 ways. You can do your sine divided by your cosine, which is how we've been doing it, or you could use the TOA, which is going to give you the same answer. So my opposite of theta is 5, and the adjacent is 12, technically -12. Now, if I was going to do the sine divided by the cosine, I would have 5/13 divided by -12/13. And reminder that the 2 denominators would cancel, and you would end up with 5/12, which is the same exact answer. Number 4 says, if the cosine of theta equals a, where a is greater than 0, which is kind of they just, like to confuse you. It's always going to be greater than 0. And the terminal ray of theta lies in the 4th quadrant, then which of the following gives the value of tangent in terms of A? So this is an interesting question because it wants to know the tangent. It's giving us the cosine. They're telling us that the cosine is A, which is interesting. They haven't really ever done that before. But we don't know anything about the sine. Now, if I were to try and graph this up on the 4th quadrant, right? Here's my theta. They don't give me enough information in order to find the sine. So what do? There's something else that we can do that I haven't talked about in this lesson, but it was a big part of earlier lessons. It is the Pythagorean identity. Remember that? Anybody know what it is? The cosine squared of theta plus the sine squared of theta equals 1, because it was the unit circle. So if I know my cosine, I can use this to find the sine and then eventually the tangent. So I know that my cosine is A, so I have A squared. I don't know my sine. That's what I'm trying to find. So I'm going to subtract my A squared from both sides. Okay. I can't actually subtract that, can I? Of course not. Now, my sine is squared. I want to get rid of that squared, so I'm going to take the square root of both sides. Square root cancels a square. So the sine of theta equals, there's nothing I can actually do there. On the right side, the square root does not cancel the square because I have this 1 here, that A squared is not alone. So I'm just going to leave it like that. So that is my sine. Interesting. So if I'm now going to find my tangent of theta, which is the sine divided by the cosine. Well, I now know my sine. It's 1 minus A squared, the square root of 1 minus A squared over my cosine is A. So that is choice. Ooh, interesting. My choice is not there. Did I mess up? Well, I wouldn't say that I messed up, but I forgot a big piece of information here. I am in the 4th quadrant, right? So when I'm finding my sine, my y value is negative. So my y value here should have been negative. So when I plug that in, it's negative. So that gives me choice 4.